Hello everyone. So far I discussed about in this chapter kinetic energy, and before that work we defined as product of force and displacement. After that kinetic energy. Kinetic energy is energy possessed by a moving object with a velocity v. So we write the kinetic energy expression: kinetic energy equal to half mv square. So moving objects having kinetic energy. So kinetic energy is also defined as the work done in terms of kinetic energy, or if you want to interrelate between kinetic energy and the work. So work is nothing but change in kinetic energy. So that is another formula we got it at here. The work done equal to change in kinetic energy. After expressing kinetic energy, so I tried to explain about in detail potential energy. So the potential energy having the stretched string or stretched spring and the stretched bow. So these objects, strings and springs, so these objects will store the work whatever we did in the form of potential energy. So potential energy also defined in terms of height. Potential energy of an object due to height. So if an object is certain height from the ground, from the above ground, so because of acceleration due to gravity, so this object having potential energy. Potential energy formula we will express as it's mgh. How did this formula came at here? So that is from work. Work formula equal to force times displacement. Displacement equal to h, and the force, we can write that force F equal to ma, Newton's second law. But here a equal to not acceleration, since it is not moving by external force, it is falling due to acceleration due to gravity. So because of the gravity it is falling, gravity is applying force on it. Now we can express this work as potential energy equal to mgh. So this potential energy also known as gravitational potential energy. So we can define potential energy as a simple manner. Energy due to its position. Energy due to its position. If object is having energy due to its position, so that energy we known as potential energy. If height is more, potential energy is more. So that's the reason water tanks are kept at height. And one more point while we discussing potential energy. Potential energy is independent of path. What does it mean? That suppose you are lifting an object from ground to a height h. You want to keep the object above certain height. It means you have to lift, means you need to do work. So whatever work we do, that consumes our energy. Okay, now what work I did, that work will be stored in the object at that point in the form of potential energy. Now instead of if you are lifting a straight like this in the figure A, but if you change the path, it means from down to here you lift it, then after you move left side, then after straight you lift it, then after you move right side, then after you can reach the same point. Now in the both the cases height is remains same, but the way you lift it, that is only different. So that we mentioned in terms of path. So in the first case path is straight, in the second case the path is not straight, but in the both the cases the object having equal potential energy, that equal to mgh. So when it comes to this point, we say that potential energy is independent of path. It's only depend on initial and final positions of the object. Where is the initial positions? It is on the ground. And where is the final position? It is at here certain height. It is only depend upon initial and final position. It do not depend on path it has carried. It do not depend. Okay. So today's class I would like to discuss next concept, which is known as law of conservation of energy. So in the previous chapter we learned something about conservation, especially conservation of momentum. Momentum is conserved. Conserved means remains constant. It do not change. At here, we need to talk about conservation of energy. So especially we will talk about mechanical energy. Mechanical energy means potential energy, kinetic energy. So in this universe, energy is conserved. But when we do work or when we do anything, whatever the energy we are having, that is converting in the form of another energy. Now right now I am speaking at here. So to speak, I am spending my energy. So whatever energy I am spending at here, that is converting in the form of sound energy. Yeah, sound is a form of energy. So the energy is just converted. It cannot be created and it cannot be destroyed. So according to law of conservation of energy, energy neither created nor destroyed, but it can only be converted from one form of energy to another form. So many examples you can talk at here. Law of conservation of energy. So mostly if we can see at here, a general example if I talk, yeah, sun is a source of energy. And we know that plants need sunlight in the process of photosynthesis to prepare food. So without sunlight, plants, they cannot prepare food. So what is the energy is there in the sun? That energy is used by the leaves to create or to generate food. So that is also one of the example of energy conservation. Or you know mostly that light energy is converted in the form of electrical energy. I think you know about solar cells, solar plates which are used in the satellites. So they are converting light energy into form of electrical energy. So like that, energy is converted from one form to another form. So in our present situation, we need to talk about how the energy of potential energy is converted into kinetic energy. Let us see one example. So with that example, we will try to understand very clearly. Now here, a skater is ready to launch. Now if I can play this one, so he goes all the way down and he goes all the way up, and again he goes down and he goes up. So let us take a situation at here. Suppose initially he is at there. Now if I calculate his potential energy, here I am having scale. You can clearly see it here. This is given in terms of meters, and this is a height of 6 meters. If I take his mass as simple as maybe 50 kg and acceleration due to gravity g, for calculations 10. If I take 10 meter per second square and the height h equal to 6 meters. So this skater at this point having potential energy. Yeah, since he is at a height from the ground, he is having potential energy. So what is his potential energy value? Just multiply everything. Potential energy formula equal to mgh. We know that. Equal to mgh. So if we can calculate that, 50 times g10 times height 6. Energy units joules. So if we can do that, it becomes 500 times 6 goes to 3000 joules. So now the skater at here he is having 3000 joules, that is energy. So that is his energy. I will clear the screen so that you can understand it carefully. Now at this point he is having potential energy equal to 3000 joules. Not only that, here I am having the bar graph. So the bar graph represents that at this point, if you can notice at here, he is having only potential energy. The potential energy bar graph is at there. Now if I play, what he does? He moves. So he is moving. Now if I stop at here. So at this point he is having two energies. So energy due to height, now this time the height is this much, and energy due to motion. So he is having two energies, one is kinetic energy and another one is potential energy. If you can see the bar graph at here, so his potential energy is decreased. Yeah, potential energy decreases because his height is decreasing. So his potential energy is decreased and kinetic energy is increased. Now I am asking a question at here. How did he get kinetic energy? So when you take him to again at here, now he is only having potential energy, that is only his energy, but when we play, he is moving. Oops, he is fallen down. Right here, you be here. Yeah. Now when I play, his potential energy is converting into kinetic energy, and again he reaches to other side, is reaching to the same height. So he is having again same potential energy. So here the velocity, the motion causes kinetic energy. That kinetic energy is coming or is caused due to because of the potential energy. Now here let us try to pause him at center, at here. Suppose if I take him at here, oops. Now let at bottom, at very bottom. So he is at there. Now when he is at there, what is the potential energy? Potential energy equal to 0. Why? Because he is on the ground. There is no height. Height h equal to 0. If height h equal to 0, his potential energy is equal to 0. If his potential energy at here equal to 0, but when he is at the top at here, his potential energy is maximum, but when he comes to all the way from there to at the bottom of the hoop, so his potential energy becomes 0. So now what happens at here? The potential energy from all the way to at here, the potential energy is converted into kinetic energy. So at the bottom, his potential energy equal to 0, but his kinetic energy is maximum. So that let us observe one more time at here. Suppose if I place him at here at 6 meters, if I can release, if you can observe the bar graphs carefully, when it comes to at bottom especially, now his potential energy became 0. The entire potential energy is converted into kinetic energy. So at the bottom at here is only having kinetic energy. So that kinetic energy is also very high, maximum. But when he is moving further, if you can observe very carefully at here, when he is moving further, so what is happening? His kinetic energy is decreasing and his potential energy is increasing. Yeah, that happens. Suppose when you are climbing uphill, what happens? Our velocity decreases. So that causes to increase our potential energy because we are reaching to the height. So again when we come back down, our velocity increases. At the down, velocity 0, velocity becomes maximum, at the bottoms, velocity becomes maximum. Again when we reaches to the same point, same height, the velocity will become 0. So here velocity will become 0, his kinetic energy equal to 0. So as the points, if I can write at here, 3 points I can take all over this way. So here the first point A, and at B and at C. So let me write the first potential energy. Here potential energy equal to mgh. I have taken h equal to 6 meters and I calculated here potential energy at A equal to, I got it 3000 joules. So here potential energy equal to maximum. And when it comes to C, it is also at the same. So at C also potential energy equal to 3000 joules. Okay, but when it comes to B, is potential energy equal to 0 at bottom of the hoop. So why is potential energy equal to 0? Since height h equal to 0. I think you agree with me. So that's the reason at point at here the potential energy is maximum. What about kinetic energy? At point A, if I write the kinetic energy with the yellow color, so kinetic energy at here equal to 0 because he is not moving. And when reaches to other end, his kinetic energy again becomes to 0. But when I make him to move, what is kinetic energy at point B? Now here you can see at point B his kinetic energy is maximum. Means he is having only kinetic energy at point B, at the bottom of that U-shaped curve track. So his potential, his kinetic energy is, now here I can write 3000 joules. Why? Because entire potential energy is converted into kinetic energy. And when I play him again, his potential energy increases and kinetic energy decreases. So this is how potential energy, kinetic energy increases and decreases. So but what is our concept? Our concept says that the total energy remains constant. So that is nothing but law of conservation of energy. So in the bar graph, I am asking to now you just observe about that total energy from the beginning to now he is at another end. Now here you can see the total energy graph is always remains the same. It's not changing at all. Even the potential energy, kinetic energy increasing, decreasing. But total energy throughout his motion, throughout his track, remains constant. So his total energy remains constant, then we say that this is known as law of conservation of energy. The energy remains constant. If I write that as formula here, kinetic energy half m square plus potential energy mgh, which equal to constant. So one point I would like to highlight. So especially in this case, we neglected the force, friction force. Neglect friction. So there is no friction between the wheels of the skate and the track. So how the potential energy converts into kinetic energy and kinetic energy converts into potential energy, but the total energy remains constant. So this is known as law of conservation of energy. As a statement, we can say that energy neither created nor destroyed. It just transforms one form to another form. So that is definition of law of conservation of energy.